In this video, we're going to take a look at writing equations for the reactions of acids with things like bases and so on, and we're going to investigate how we get the names of the salts and then how we get the formulas and then eventually lead to the balanced equations. Now, let me do a quick reminder of those reactions we showed at the end of the last video, which were the three reactions that neutralize acids. So three things that neutralize acids. First of all, alkalis. And you remember there's not very much to see in terms of the reaction with alkalis. So we simply mix them and you'll see colourless liquids become colourless liquids. But if you watch, you'll see the temperature goes up. So it's at what we call an exothermic reaction. It's one that gives out heat. So the reaction is acid plus alkali gives us salt plus water. Now, do you remember we're going to demonstrate shortly the salt is in there. Now, the acids we use are dilute. So they've got lots and lots of water. So once you've neutralized the acid, you have salt and water in the beaker. And if you heat that beaker and evaporate off all of the water, you're left with the salt. So that white stuff that's starting to form there, that's the salt with all of the water removed. And so acid plus alkali gives us salt plus water. And there we can see the salt. So acid plus alkali, salt plus water. Now, a base and an alkali are practically the same thing. There's a slight difference which we'll maybe learn in year 12. A base tends to be things like metal oxides, and this is some copper oxide, and you can see a fairly vigorous reaction, so it's quite exothermic, so that's quite a bit of steam being given off there, that's what the bubbles are. But you see the blue solution, and that's copper sulfate, that's a salt. So copper oxide has given us copper sulfate. So acid plus base also gives us salt plus water, and we'll talk about that in the reactions in a moment. Then we've acid and carbonate. Now this time we've set it up slightly different. In the right hand tube over here is some lime water. And you'll see as the reaction takes place, lots of fizzing here, bubbles pass through the lime water, and that has gone milky. So that is carbon dioxide being given off. So we'll show that with our reaction in a moment. And then finally, acids can be neutralized with metals. And you'll see lots and lots of fizzing there as the metal has gone into the acid. And then again, the acid's being neutralized, there's a salt being made there, and in a moment you'll see a flame come in, and we get a pop. And that's a sign that hydrogen gas was given off. So, four things neutralize acids, and to help you remember that, I always think of A, B, C, alkali, base, carbonate. So alkalis and bases are more or less the same thing. They tend to be metal oxides and hydroxides. So alkalis, if you put down things, if you've got things like sodium hydroxide, potassium hydroxide, calcium hydroxide, they're alkalis. Oxides tend to be bases, copper oxide, magnesium oxide, and so on. And we'll come across those a wee bit more later on. So acid plus alkali gives salt plus water. Acid plus base gives salt plus water. Then carbonates, so that's the C bit, alkali and base AB, carbonate C, they also give us salt plus water. But remember we also saw the bubbling, and the lime water went milky, so we had carbon dioxide given off. So acid plus carbonate, salt plus water, same as before, but you also get carbon dioxide. And the carbon in there hopefully reminds you to put carbon dioxide there. And then finally, acid plus metal. Now we tend to use the middle reactivity metals, things like magnesium, zinc and iron, and they give us a salt. So you'll see in all four cases the salt has been produced, and then we got that gas that popped, hydrogen. So acid plus metal gives salt plus hydrogen. Now a couple of questions that sometimes come up. Why do we use those middle range metals? Why do we not use the ones at the top? Well, potassium and sodium, they react with acids, but far too explosively. So they're so reactive that there would be an explosion. It's too dangerous. So we never put potassium or sodium into acid. On the other hand, those metals at the bottom of the reactivity series, copper, silver and gold, they're too unreactive. In fact, they don't react with acids. So they're simply too unreactive. So that's why we use those middle range ones. We want ones that give a good reaction and get the salt, but we don't want ones that either don't work, too unreactive, or ones that would explode. So potassium, sodium, don't put into acid, silver, gold, and so on. We don't either because they don't react. Okay, so if you want to complete that at the top half of page 11, and then what we're going to do is we're going to go over how we get the names of the salts and then how we get the formula. Okay, so there are basically three acids that we have to know about. One has popped up earlier with my animation there, nitric acid. So sulfuric acid, hydrochloric acid, and nitric acid. Now, how do we get the names of the salts that are made? Well, the three acids, if we put our formula down, sulfuric acid H2SO4, hydrochloric acid HCl, and then nitric acid HNO3. Now, you remember what makes acids acids? They give off H pluses. So if you took those H's of sulfuric acid, what you're left with is SO4. Now, do you remember on our data sheets, there's the two bits of our data sheet, there's the front and there's the back bit. So if we go to SO4, that's sulfate. So if you take those two H's of sulfuric acid, it's going to leave you with sulfate. So every time you react sulfuric acid, the salts are called sulfates. Hydrochloric acid, HCl, take that H off, you're left with Cl. And Cl is chlorine, so a compound containing chlorine is called a chloride. So hydrochloric acid makes salts called chlorides. And nitric acid, HNO3, take that H off, you're left with NO3. And if you go to your data sheet, you'll see NO3 is nitrate. So nitric acid makes salts called nitrates. So every time we use sulfuric acid, our salts are going to be called sulfates. When we use hydrochloric acid, chlorides, nitric acid, nitrates. Now, let's do some examples. So I'll do some examples on the screen. If you want, if you're happy enough with them, you could try these. What we're going to try and do is work out the name of the salt and then the formula. And if you're happy to try it, pause the video when you see the example is put up, and then see if you can get the name and the formula. And particularly after I've done the first one. So let me do the first one, then you can see the ones after that. And if you're happier just to listen to it, then play it through, and then you've got a few to do yourselves on page 11. So the first one, what if magnesium reacted with hydrochloric acid? Well, if magnesium reacted with hydrochloric acid, the two things we want to work out is the name of the salt and the formula. So, name of the salt, well, we take the metal part from this as magnesium. Hydrochloric acid, do you remember that loses its H, so Cl, chlorides. So remember that phrase, hydrochloric acid makes salts called chlorides. So magnesium, and then from the hydrochloric acid, chloride. So the salt is magnesium chloride. How do we get the formula? Well, magnesium, Mg. So there's Mg, it's group 2. And you remember I've put in red there that little trend in terms of your numbers. So magnesium, every time we use magnesium, plus 2. Chlorine is here, Cl minus 1. So we'll need 2 chlorides for every magnesium to balance up the pluses and minuses. And that gives us MgCl2. So the name, magnesium chloride, the formula, MgCl2. Okay, next one, iron reacting with hydrochloric acid. Now, when iron reacts, it tends to give us iron 2 salts. So you'll see over here, iron 2 is Fe2+, so it's charged 2+. So, see if you can work out the name and the formula. So, iron, hydrochloric acid, that's going to give us iron 2 chloride. Yeah, so iron 2 chloride. Formula, Fe plus 2. Cl minus 1, need 2 chlorines for every iron, so FeCl2. Next one, potassium hydroxide with nitric acid. So could you work out the name of the salt? Yep, potassium nitrate, isn't that right? So potassium from this part, nitric acid makes salts called nitrates, so we take that H off, we're left with nitrate. So K plus 1, nitrate, NO3, and then the minus above it, minus 1. We don't have to do anything to balance up the numbers, so KNO3. Next one, sodium carbonate reacting with sulfuric acid. Name of the salt, formula. So, name sodium from this bit. Sulfuric acid makes salts called sulfates, sodium sulfate. Formula, Na plus 1. SO4 minus 2. This time we need 2 plus 1s to balance that up. So Na2SO4. And last one that I'll do on the screen here, calcium hydroxide with sulfuric acid. Name of salt, formula. So the name would be calcium sulfate. And the formula, Ca over here, plus 2. Sulfate, SO4 minus 2, and that means we've balanced it up, so Ca SO4. Okay, so see if you can then do the examples in the bottom half of page 11. So pause the video. You could leave that screen up. That's got the data sheet. If you want, you can get your own data sheet. It'll give you a bigger copy of it there. And remember the information that I have up on screen there. That's on the front of your data sheet. That's on the back. And then you can try those examples on page 11. And in a moment, I'll go over these. So you pause the video now. Okay, so going over the answers. So magnesium and sulfuric acid should be magnesium sulfate, and then Mg plus 2, SO4 minus 2, MgSO4. Copper 2 oxide and sulfuric acid, that would give us copper 2 sulfates, Cu plus 2, SO4 minus 2, so CuSO4. Sodium carbonate and hydrochloric acid, sodium chloride, Na plus 1, Cl minus 1, NaCl. Calcium carbonate and nitric acid, calcium nitrate. Now this time Ca plus 2, NO3 minus 1. Now we need 2 nitrates, so you remember that we have to bracket that. So Ca brackets NO3, 2. Zinc chloride, zinc and hydrochloric acid, zinc chloride. Zn plus 2, Cl minus 1, ZnCl2. Potassium hydroxide and hydrochloric acid, potassium chloride, K plus 1, Cl minus 1, KCl. Calcium carbonate and hydrochloric acid, calcium chloride, Ca plus 2, Cl minus 1, CaCl2. And sodium hydroxide and nitric acid, sodium nitrate, Na plus 1, NO3 minus 1, NaNO3. Okay, so to put this into balanced symbols equations, let's take a look at this. Now we'll put these bits of information together. So at the start of this video, we saw the idea of acids, alkalis, bases, carbonates and metals all reacting together. So that's our 4 equations. So try and remember that. Now you'll see when I'm getting you to practice, I'll leave a screen up with all of these to help you. In an exam eventually, you'll try and remember those. So as I said before, remember A, B, C, alkali, base, carbonate, all are salt plus water, and then carbonate, carbon dioxide. And then acid plus metal, salt plus hydrogen. Couple of formulas to try and keep in mind. Hydrogen, every time we've got hydrogen gas, so when we're putting hydrogen here in this equation, we use H2, and then hopefully you're familiar, carbon dioxide and water, CO2 and H2O. And our formulas for our acids, those again we have to commit to memory. H2SO4, HCl, HNO3. So let's try and put these all together. So first of all, magnesium and hydrochloric acid. Well, magnesium obviously is a metal, so it's going to be this one here, acid plus metal, and that's going to give us salt plus hydrogen. So what would be the name of our salt? Well, magnesium and hydrochloric acid. Hydrochloric acid gives us chlorides, so magnesium chloride. So our salt's magnesium chloride, and then because it's acid plus metal, salt plus hydrogen. So hydrogen is our other product. Now, in terms of formulas, so we're fairly straightforward. Mg will just be, or magnesium will just be Mg. Hydrochloric acid we've got here, HCl. Now, magnesium chloride, we may need to use our data sheet for this. So magnesium is here, plus 2. Chloride is here, Cl minus 1. So we'll need 2 chlorines for every magnesium, so MgCl2. And hydrogen, yeah, remember we said use H2 for it, H2. So that basically, if that was a question in the exam, that's 2 out of the 3 marks. Now, the last thing that we have to do to get our 3rd mark is balance it. So if you look at it, you'll see that there's 1 hydrogen here, there's 2 over here. Similarly, there's 1 chlorine and 2 here. So we need to double the number of hydrogen and chlorines. So we do that, remember, by putting a 2 in front of it. So there's our final balanced equation. Mg plus 2HCl gives us MgCl2 plus H2. Another example, sodium carbonate and sulfuric acid. So let's recognize the type of reaction first of all. So it's a carbonate, so C. So it's this one, acid plus carbonate, salt, water and carbon dioxide. So we're going to get the name of our salt in a moment, and then water and carbon dioxide. Now, what is our salt? Sodium and then sulfuric acid. So sulfuric acid makes sulfates. so sodium sulfate. So sodium carbonate and sulfuric acid, sodium sulfate. And then the other two products are up there, water and carbon dioxide. To put our formulas in, now we need to go to our data sheet. So sodium is Na plus 1. Carbonate, we've got it here, CO3 minus 2. So we'll need 2 sodiums, 2 plus 1s, 1 minus 2, so Na2CO3. Sulfuric acid, H2SO4. Sodium sulfate, let's go back to that data sheet. Sodium, Na plus 1. Sulfate, SO4 minus 2. So we're going to need 2 sodiums for every sulfate, so Na2SO4. So Na2SO4. Water, H2O, carbon dioxide, CO2. And when we do that, that's 2 out of the 3. Let's check the balancing. 2 sodiums, yep, they're balanced. Now, carbon, there's 1 there and 1 there. Oxygens, you can do it one of 2 ways. Well, you can see you've got SO4 and SO4, so those oxygens there are balanced okay. There's CO3 here, we've got CO2, but don't forget we've also that O. So when you total it up, the oxygens are actually balanced. If you want to do it another way, 3 plus 4 is 7, 4 plus 1 plus 2 is 7. So oxygens are balanced. So that equation is balanced. So you get the mark for doing nothing. In other words, don't put any numbers in front of it, and you've got it correct, you've got it balanced. So there's the mark for your equation. Next one, potassium hydroxide and nitric acid. Now, the type of reaction, hydroxide, so oxides or hydroxides or alkalis or bases. So probably better to call that an alkali. So acid plus alkali, salt plus water. So our salt, potassium nitrate. Remember, nitric acid gives nitrate, so potassium nitrate. And then because acid plus alkali, salt plus water, water. So there's our word equation. Symbols, let's go to our data sheet. K, and then hydroxide is there, OH minus 1, so KOH. While we're here, let's do the potassium nitrate. K, again plus 1, nitrate NO3 minus 1, so KNO3. So KOH, potassium hydroxide, nitric acid, up here, HNO3, potassium nitrate, KNO3, and water, H2O. In terms of balancing, 1 potassium, 1 potassium. Oxygens, 1 and 3 is 4, 3 and 1's 4. Hydrogens, 1 and 1's 2, 2 over here. Nitrogens, 1 and 1. So that's actually balanced as well. So leaving the numbers off will give you the 3 marks there. Then potassium hydroxide and sulfuric acid. So again, what have we got? Potassium hydroxide, so it's going to be an alkali again. Acid plus alkali giving us salt. The name of our salt, potassium sulfate. And then because it's acid plus alkali, salt plus water. So potassium sulfate plus water. Then getting our formulas, K and OH from here. So KOH will be potassium hydroxide, sulfuric acid, H2SO4, put that up again in a second. Now potassium sulfate, K plus 1, sulfate SO4 minus 2. So we need 2 plus 1s and 1 of those that's got SO4 minus 2, so K2SO4. So KOH, potassium hydroxide, H2SO4 sulfuric acid, K2SO4 potassium sulfate, and water, H2O. Now, this time it's not balanced because we've got 1 potassium here, but we've got 2 here. So we need to double the amount of potassiums by putting a 2 in front of that. That now gives us 2 times 1 is 2 oxygens, plus those 4 is 6. We've 4 and only 1 here. So we need to double that number of oxygens there. So put a 2 in front of it. So 2 times 1, 2 plus 4, 6. 4 plus 2 times 1, 6. And then if you check the other things, H2 and then 2 H's there, so 4 hydrogens. Yep, we've got our 4 hydrogens, 1 sulfur, and that's it balanced. Okay, and final one, copper oxide and sulfuric acid. That's the one we saw in the video at the start of this, the little reaction. Now, what is this? Copper oxide is a metal oxide, so it's a base. So the name of the salt, copper sulfate. And then the other product, because we had acid plus base, salt plus water. Formulas, let's go to our data sheet. Now, copper is 2, so we're using that Roman numeral, so plus 2. Oxide is O, so minus 2, so CuO for copper oxide, Cu plus 2, O minus 2, so CuO. Sulfuric acid H2SO4, copper 2 sulfate, Cu plus 2, sulfates SO4 minus 2, so CuSO4. So CuO, H2SO4, CuSO4, and H2O. And again, if you check either side of that, that's balanced. So we've got those correct there. Okay, so I'll leave that blank screen up, and if you try the examples on page 12, you'll see that you've got the bases of them. So whenever you put it up, I'll put it back to that blank screen there. So you'll see you've got the basic of the reaction. So first of all, it says sodium hydroxide and hydrochloric acid. Work out the word equation. So for that first one with a bit of a clue, sodium hydroxide, remember, is an alkali. That's an acid, so it's going to be acid plus alkali, giving you salt plus water. So then put the specific words, sodium hydroxide, hydrochloric acid, name the salt. Sodium and hydrochloric acid reacting together, give the salt, and then acid plus alkali, salt plus water. So put down your full word equation there, sodium hydroxide and hydrochloric acid given whatever salt you get plus water, and then put your symbols underneath it. And then once you've got your symbols correct, balance it. Okay, so I'll put it back onto that screen there for you. And if you want to pause the video and then try those examples. And when you're finished those, if you post up your solutions, and I will give you solutions to those then in our last video on acids and alkalis, which will be the next one.